parallelograms, and what we have left are the trapezoids and kites. So when we went through the quadrilateral stuff, bless you, we had the parallelograms, and then we had the non-parallelograms. When the parallelograms you guys did the past few days, you had, well, parallelograms, rectangles, rhombuses, and squares. We did all those properties and walked through every single bit of them. All the trig, all the right triangles, we did the coordinate parts and all of that. So we've done that. That's kind of where we're at then. Now we go to what are the non-parallelograms. There's really only two of them. It's the kite and the trapezoid. With the trapezoid, though, there will be two types, a generic and a more specific. So the non-parallelograms if we start with the trapezoid. Trapezoids have one set of parallel sides. They only have one set of parallel sides. What happens with that is that I want you to start thinking of it in terms of parallel lines cut by a transversal. And you have two sets of them, if you start thinking of it that way. And when you have a, excuse me, if I have something that looks like that and you have two parallel lines that are cut by a transversal, what's the relationship between those two angles then? They're supplementary, very good. What happens is you get, I want you, it's not like a property or anything like that that's ever really defined through, but I always want to show you guys what happens because I know where the questions and the things like that happen with the homeworks and quizzes and all that kind of junk. Is that you get two sets of, let's see, the two angles between the parallel sides. Think of them as, we call those what, consecutive interior? That are supplementary. It does not mean that any one of those four angles winds up being congruent because they won't be. I mean, they could be, but more often than not, they're not. But you do know that the two angles that are above one another, like that, when they're between the two sets of parallel lines, they will always be supplementary. So these two angles on this side here would be supplementary, and these two angles would be supplementary. There's no relationship between them when they're on that same part of the parallel part, on the parallel line side, or on the other parallel line side. Yes, sir? Yes, they could be. Okay? They could be. Now, there are times where you could have a trapezoid that could look like this, and it shows up from. I think there's actually a problem tonight that looks like this. Remember? Oh, geez, this would have been back in chapter 3 when you have, if you have a line that's perpendicular to two lines, those two lines are always parallel to one another. So it is completely possible to have the two parallel lines with a trapezoid where one set of the angles are both right angles. Perfectly, totally fine. The other set won't be. Because if the other set was, it wouldn't be a trapezoid, it would be a rectangle. Okay? That's how that works. So you could have something like that without a problem. That shows up a lot, actually. Okay? These are still, if it's parallel, they're still supplementary, aren't they? 90 gives you 180. So it still works. But that's like the only time that you can have any of them being congruent is if one of the sets, it happens to be perpendicular. Yeah?
So you think
Oh, I could, because if I cut this through, how many non-overlapping triangles do you make? How many degrees are there then? 360. It doesn't matter. It's still got 4 sides, so it's still gonna have 4 angles. So it's still gonna add up to equal 360. It'll still work. Okay. That idea still happens. Okay. That still happens like that. Does that make sense? I mean, this can happen where you get one side being perpendicular. It's not a big deal. The other side might not be, but it still works out to be a parallelogram because you just have the one set of parallel sides. All right. Now, the one that you guys are probably more accustomed to seeing is what they call the isosceles trapezoid, because it mirrors the same idea of as an isosceles triangle. What does an isosceles triangle have? It has 2 congruent sides. So what you're accustomed to seeing probably is what they call an isosceles trapezoid. It's more specific. The isosceles trapezoid still has just one set of parallel sides. Because that's what makes it a trapezoid, just having one set of parallel sides. But by it being isosceles, just like an isosceles triangle, the legs, the parts that connect the parallel parts, those two will always be congruent. Those will always be congruent. And then think about the isosceles triangle. If you go back and think about what an isosceles triangle does. If those were congruent, what else happened? The angles. We call them base angles. Those would be congruent. Well, in a trapezoid, which ones are the base angles?
The top.
Which is which?
The shorter one's on top.
Now what?
That's the bottom and that's the top. You just flipped it.
But is where the positioning relevant?
Well then, because these are the 2 top ones and the 2 top angles are congruent, right?
Okay.
And the 2 bottom angles are congruent.
Okay.
So does it matter if they're top or bottom? Because those, like the top flip. Yeah.
What if they're that?
Well then the 2 side angles are congruent. So the 2 that are next to each other.
Why would you?
Yeah.
All right, hold on. Go with where I think I know where you're going. Where are you going?
The 2 right next to each other on there.
Two right
You
across.
keep changing it. Okay. No, because then he's gonna move it again and then make it.
No, hold on. I think I know where you're going. You see the 2 next to each other. All right.
Okay, go up there.
Which 2 being next to each other? Be more specific. You're on the right track.
The top right.
Just go there and show
Let her
them.
show you.
Yeah,
But
show
what
them.
happens if I move it?
Well then, okay, no, put it back. I take that out.
What?
Okay, so you know how you put the dash saying that those are congruent?
Yes.
So the ones that go with those.
You're so very close in explaining this correctly. Yes, ma'am. The ones that, okay, that's good, and that's, you were so close to say that. I was wondering if you were going to say the ones that are shared on the parallel part. I thought that's where you were going. Well, I thought that's where you were going. But what you were saying is the ones that are created by the congruent parts, the ones that they're looking at. If you think of it just like you did with the sides with the triangles, the side lengths always looked at the base angles. Well, it just so happens that these have 2 base angles to look at. The base angle positioning doesn't matter. They're just called base angles. It's just a very generic term. And you're right, they're the 2 sets the sets that are non-opposite are congruent. Consecutive non-opposite angles. Would that be right?
Yeah.
Well, no, that wouldn't be right, because then those could be congruent. So ones that are shared, angles that are created by the side and the parallel in the same positioning or whatever. The base angles,
Same thing.
same thing. And you're right, it's tough to describe it in the technical sense, but if you think of it as bases And as you were saying, top and bottom, blah, blah, blah. But that's how that works. So isosceles trapezoid has a couple things. Congruent legs and congruent base angles. Or two sets. Alright, so we have two legs that are congruent and two sets of base angles that are congruent. There's one other piece that shows up from time to time with these things, is that the diagonals of any isosceles triangle are always congruent. The diagonals of an isosceles trapezoid are congruent. Yeah. It doesn't say that they intersect to form right angles or anything like that. All it's saying is that you get congruent diagonals. That's all. So your isosceles trapezoid is more specific than just the generic, hey, look here, there's a trapezoid. Yay. Right. The isosceles gets more specific. A lot of times with the isosceles trapezoid, what you'll wind up solving for, it would be like algebraically working with the angles. Obviously, like you were saying a second ago, you know that all four of them have to add up equal 360. The sets themselves would be congruent, so you do a lot of stuff like that. But let's draw this out. So we have the regular trapezoid. One set of congruent sides. Isosceles one is more fancy, or fancier. It's fancier, right? Not more fancy. This is why I teach math. Sometimes we worry about that as well.
Fancier. Oh, that's so much more fancy. Fancy.
You get those. Oh, I know. There's one other thing about trapezoids that you've actually done before. Well, you could, but one of the things that you did a long time ago with parallel lines, do you guys remember? Remember when we did, actually it was in a triangle, I believe. Remember when we did something like this in a triangle? Where we call what was this segment called? Do you remember?
Does it start with A?
Mid segment, good.
There was
The mid segment. You guys remember when we did mid segment? Mid segment was when you had the it connected the midpoints. Well, I'm reminding you. There's a thing called a mid segment. A mid segment it's a segment that connects midpoints. So in a trapezoid, oops. In a trapezoid, if we do this right, if a mid-segment is created to connect midpoints in a trapezoid, it does something else. Those two are the same. What happens is, it's also parallel to the other two bases. We call those bases. The parallel parts are always called bases. The outer edges are legs. Now in this case, this mid-segment, we did this with similar figures, if I'm not mistaken. When you had a mid-segment, the mid-segment is equal to half the sum of the bases. That mid-segment is equal to half the sum of the bases. Now there's a couple of different ways that we can write this out. obviously, this is the most generic one. This is the way that most textbooks will write it out. They always put things with fractions. Now, knowing how much you guys absolutely love fractions, I will show you in another way. So the mid-segment is equal to half.
Is the line with the two slashes and D, is that a 90-degree angle? I just can't tell.
No, if it was 90, I would have made it a 90.
Okay.
Yeah, this is that parallel arrow, sorry.
Okay.
Okay. It could be, but I didn't say it was. Because remember the one I had over here a second where it was perpendicular? You could still have the mid-segment in that.
Okay.
It does. In trapezoids, you'll have them all the time.
I couldn't tell if it was straight or not.
Now, what's one way that you could get rid of a fraction? Multiply by what? Reciprocal, good. What's the reciprocal of a half? 2/1. So if I want to do this and I want to get rid of this fraction, another way to write this out is the following. If I multiply both sides by 2, the fraction goes away and I get, if I double the mid-segment, it equals the sum of the bases. Okay? So there's two ways of going about working with what are called mid-segments. It is, it's really dependent upon what you're more comfortable with. Some people are comfortable working with fractions, some people aren't. It's not a big deal. Okay? We did this before where we had halves. We got rid of it. What was that? I think it was something with mid-segment. Wasn't it where we had halves or, I don't know, it was something. So what happens here is we can do this. No, I don't want, we'll do this one. If I want to solve for x, there's actually, believe it or not, there's actually going to be 3 different ways to do this. I will show you both formulaic ways, and I will show you a way that you can kind of think your way through it. Remember when we did midpoints and we did missing endpoints long time ago where we just counted up and down? We can kind of do the idea of thinking through a lot of these problems the same way, especially if numbers are kind of normal when they give them to you. Okay? So in this case here, we've got a trapezoid. It's not an isosceles trapezoid because you've got 2 tick marks for both segments on the one side and 1 tick mark for the ones on the right. So it's just a regular old boring trapezoid. The mid-segment is given to you at 7. The bases are 10 and 2x. So what happens is there's 2 different ways formulaically you could write this out, and I'll show you. The mid-segment is 7 equals half the sum of the bases. That's one way of doing it. Using a fraction here isn't so bad because the bases, both values for the bases are even. What's half of 2? What's half of 5? What's half of 10? 5. So one way is you could have distributed the half to both parts because it's not bad because it's just even numbers. 7 is x plus 5 and you get x equals 2. Not too bad. The other way, if you wanted to not worry about fractions right off the bat, I would say if I double my mid-segment, it will equal the sum of my bases. So what's 2 times 7? What's 14 minus 10? 4. And what do you get for x?
1.
2. You get the same exact result. Just like I say though, sometimes people don't mind working with fractions. It's not bad when they're even, but if they're not or you just don't want to deal with it, just double the mid-segment and make it work. Or, do they give you numbers for a mid-segment and for a base? Do they give you an actual number or is it all algebra? We have actual numbers here. So, I want you to kind of think about this then. From 10 to 7, numerically, do you go up or down? How many? 3. So that means I have to go down 3 more to get to the other one. What's 3 less than 7?
4.
So this segment has to equal 4. What's x?
2.
There's a couple of ways of doing that. And we did that exact same thing when we did missing endpoint.
Does that work every time?
Yeah.
It's gonna work it's only gonna work if you know numbers for 2 of the 3. If you have numerical values for 2 of the 3, it'll work. If you don't have numerical, you won't know what to count to.
Okay.
Because eventually, I don't know if we'll get to it today, but tomorrow and probably parts of Friday, we'll have a lot more algebra for all 3 of those things, where you just have to distribute and solve for x, which just becomes a multi-step problem. But when they're numbers like this, yeah, just count.
Okay.
All right?
That's
It's quick. It works. And it's that same idea of endpoint of -3 and 4, a midpoint of 6 and 2. What's the missing endpoint? And we did that before. That's kind of the same thing, but it's just one number as opposed to an ordered pair. Okay? And these things, you guys are like, what? All I do is know how to count. No, that was exactly what your face was when we did these. Yeah, it was. All right. Because your voice is higher than mine, so it would have been like that. Am I right?
He is funny. Sometimes.
Probably not.
Let me show you the other one then.
Sometimes I think it's funny when he speaks just
5 to 8.
sometimes short. Gosh, we're working hours. No, you're not.
I just want you guys to, really try, and that's it bothers me. It bothers me when you guys don't want to try.
He just wants us to be successful.
I don't ask for much.
I saw Kevin yesterday walking the dog.
That's great.
I yelled at him.
That's awesome. You've got your post-it note in your hair. It's a spider. It's a spider.
Oh, sorry.
Same idea.
Sorry, Lizzie.
Hey, why haven't we been doing the fridge?
We've been forgetting.
Oh.
Well, I promise. Next one we do, we will. All right.
I think
Someone's
someone's
going to be
funny
for
him, to be honest.
Same
So
idea.
That one we can't.
We can
Why?
because do you have one of the bases and the mid segment?
Yes.
Are they both numbers you can count to?
Yes.
Can you count to 17?
From 20?
I'm just joking with you.
What? Yeah.
Just,
You know what?
I was-
You know what?
Okay, so we'll do
This
this
is
the
why I don't
short. We'll
get
do this the shortcut way.
He's always trying to mess around.
17's a base, 20's a mid segment. To go from 17 to 20, do you go up or down? You went up. How many?
3.
So what's 3 more than 20?
23.
So this segment has to equal 23.
So it's
Remember, mid segment is just another name for average.
20.
If you average 17 and 23, means you add them together and cut it in half. Well, 17 plus 23 is 40. Half of 40 is?
20.
It's just, thanks for being right there. It's you can do all the algebra, but anytime you can set it up as a shortcut, by all means, go for it. It's gonna work. It'll work just fine. You'd add 5 and you get 7x. It's 28. And x is 4. It'll work the exact same way if you took the mid segment. 2 times the mid segment equals the sum of the bases. It's just extra steps. Now, don't get me wrong, there will be times where you'll have extra equations for either the base or the mid segment where you won't be able to do this. But if you don't, save yourself some brain cells. And you'll see here, you'll wind up with the same thing. -5 and 17 is 12. Subtract that over, what's 40 minus 12?
30.
28.
28.
And you still get,
4.
you get the same thing. It's just nice when you can add or subtract because it's quicker. That's all. It's one of those nice shortcuts. Good. Good. And that's the idea. I mean,
Is this our homework?
you can fall through and use formulas all day long, but if there's an easier way to do it, it's the same thing which I've been trying to show you guys with this whole thing of slope. If you're just counting slope. You know, distance formula. It's just Pythagorean theorem. It's those ideas I'm trying to get you guys to realize it's okay. Try another one.
Let's have a race.
It's not.
Okay? Same basic idea. You've got a mid segment.
Can you go from the bottom?
Yeah, it's still the same thing. It's just If it was flipped around, it would just be upside down, that's all. It doesn't matter, as long as you know if you're adding or subtracting to go from the base to a mid-segment. If you're subtracting, then you subtract again. If you're adding, you add again. That's all.
Wait, what?
So, if you're looking at this, if you're starting at 19 and you're going to 14 and a half, do you go up or down? You went down. How much? What's 19 minus 14 and a half? 4.5. So what's 14.5 minus 4.5? 10. So the other segment has to equal, it has to equal 10. Math!
Finish it first. Wait,
It's math.
wait, I need the first.
Going from 19 to 14.5, do you go up or down?
Down.
How many?
3.
5.5. Oh, I put 9 minus 14.
There you go. So that's what you're doing. So then what's x going to equal here?
4.5.
Well,
This one's gonna work.
no, the difference between what's the 4.5.
5. Wait, what?
Slow down.
Okay.
To get from here to here, you went minus 4.5. To go from here to here, you have to again go minus 4.5. 14 and a half, subtract 4 and a half, you're at 10.
Okay.
So that segment would be equal to 10. And then you just solve through, you get x equals 3. Good. Okay. The other shape I wanted to show you here today is the kite. With these 50-mile-an-hour winds, it's not a bad idea to go outside and fly one.
Don't go out there.
Actually, I would use like a bed sheet and a chain.
I was just out
If
there.
you're rambunctious and you have a skateboard and PVC and a bed sheet, you can make a sail, and you'll wind up in Geneva. Going from the west, you go east. Anyway, a kite. The kite is made of 2 isosceles triangles. I like to build the kites by reminding you guys again what isosceles triangles do. We all know that an isosceles triangle, I'm really not good at drawing kites, so I'm sorry. We know that an isosceles triangle would do that. Agree?
Agree.
We also know that if I connect this part here, these base angles would be the same.
Agree.
Okay. Now what I want to do after that is connect a second isosceles triangle. Not being the same side lengths. Because if it was the same side lengths, it would be it could be, but what's less, yeah, it's definitely a rhombus, but not necessarily a square. So all right, see if I can do this.
Oh, messed up.
It's close.
Yeah, you're done from the beginning.
All right, it's not bad.
What if you just take from the other base and then go to that? Wouldn't that be easier?
There's your other isosceles triangle. Now again, I drew a diagonal there between those two, where those two angles would go through. If I think of this being a second set of base angles, these two are looking at its base angles, correct? Which means that these two would have to be the same. So do you remember what happens if you add two things together that are the same? What do they always equal? No.
Each other.
Each other. Very good.
Finally, she said it. I'll give her credit.
Oh. I mean, oh, it's like, oh. Good.
She knows I was thinking it, so.
Now, what I want you to see here is that you've got two smaller angles that are the same on both sides. When you add those two smaller angles, they create a bigger angle. Those two bigger angles then always are going to be equal. They're always going to be congruent. So in this kite, you have two sets of non-opposite two sets of non-opposite sides congruent. Let me draw this here. The angles between those two sets of sides are always congruent. Those two. Does that make sense how it's worded? I'm trying to word it so it's not wordy, if that makes any sense at all. Yes, sir.
Like, since this is geometry, could we go to like Six Flags and like learn the geometry?
Yeah, the angles and stuff on the roller coaster.
Can we go fly kites?
Yeah, you can fly
No.
kites.
Yeah, Nigel, go fly a kite.
I'm not asking.
Anyway, so
They just shut down the idea.
what's up? I do.
Hey, Madeline, come in.
Yes, ma'am. So, we're almost done with this one. So you've got your two sets of non-opposite sides that are congruent. You've got your angle between those two sets of sides congruent.
I also came here to ask you about the person down on that.
You owe me money. I don't know. How much is it worth? Do I get like 10% of the
Her
scholarship?
career.
Sure.
It's worth her career.
All right, thank you.
No problem. The diagonals then
Because
are perpendicular.
there are congruent.
The diagonals of a kite are perpendicular.
I don't know how.
And then there's one last little bit. I know there's a lot in this one. Remember when we did, going back to the isosceles triangle, oops, wrong button. When we had the isosceles triangle, we had this. If I drew this in, it was always perpendicular to the base, right? You wound up with reflexive, and you had hypotenuse leg, but you also knew that that happened. The height of an isosceles triangle is always the perpendicular bisector of the base. So the reason why, as you're going back through here, this segment from where the two angles are is always bisected. The other one not, but that one is. So the segment between the diagonal connecting the congruent angles is bisected. Okay. So when you see that you're going to have a bunch of different right triangles, that means, again, we're going to have Pythagorean theorem, triples, SOHCAHTOA, all that stuff. I know. It's exciting. So kites, you're going to see a lot of that as well. And going from there. Kites can get messy. Just be careful with them as you draw them out. But remember, if you remember in the back of your mind, it's just two isosceles triangles connected. You should be okay. All right. I know that there's a lot more algebra and things that we have to go with this stuff, and I just don't have enough time today to do all that. So we'll continue working with this tomorrow. Oh, we got plenty of time. What I have for you guys tonight, though, I've got not too many of these, is this. It's basically today what we're working on is a lot of that mid-segment stuff, and I don't think I even gave you any kite problems, to be honest with you, so we don't have enough time to get really into them yet. So it's a lot of trapezoids with mid-segment stuff today. Tomorrow we'll do a lot more of the kites, And we'll do a lot more of the longer winded version of the algebra, where you have that shortcut I showed you might not always work, where you'll actually have to, you know, math. I know. It's a lot. I know. It's a lot. Okay? Questions on that at all? Very good. Exciting.
That's 29 and 32 or 29?
29 and 32, yeah. Because the other one, some of the 32 is a little tricky. Let's see if you remember how to do it.
This is kind of nice. All easy units. And